It's been a really long time since I've really had a chance to sit down and record videos for the projects that I've been working on, and I tend to work on a lot of projects, at least one every day, or at least one that's ongoing. There's always something. Anyway, this is something that I wanted to get down on video just so I don't forget to do it, because I discovered something new. I discovered the ESP-12E. It's a Wi-Fi module with a microcontroller built in, and there's all sorts of things that you can do. I'm not even going to get into the technical aspects of it, but you can look up ESP-12E or ESP-12E and find out all about it. More than likely, if you look up that, what you're going to find also is this, something called the Node MCU, and there's other platforms by other companies. But this basically takes that ESP-12E that I just showed you and puts it into a breakout board that you can access all of the pins and all of the different functions that it has. It gives you a little micro USB port here to plug it in and program it. And the great thing is it's compatible with Arduino and Raspberry Pi and many other programmers. But this is how I learned about it. I was asked to do a project at work to monitor a couple of the air conditioning units on the roof and be able to control them with our phones. And someone led me to the Node MCU, which I plugged into my breadboard, I wired up, wrote a program, and instantly was connected to my Wi-Fi using an app called Blink, B-L-Y-N-K. On my smartphone, I was working a project, turning LEDs on and off, and relays and all sorts of stuff. The very basic things that I needed the project to do, in addition to alert me to when analog sensors reached a certain value. So it has an analog input on here as well, so which is kind of cool. But me, I don't like to use this development board as the main brain for the project. I really need to simplify it because I feel that it would be a big waste for what I'm doing. I mean, really, in all reality, this chip is kind of a big waste too. I could just get, what is it, the ESP-01. It just has a lot less pins, and it doesn't have the analog pin, but I could do that. Sorry about the glare. I could do that in other ways. But anyway, so my first challenge was to figure out how do I make a circuit board for this thing, because I'm going to have to make some kind of programming socket for it. Because I'm not using this guy. Yeah, I'm not going to unsolder and solder and desolder parts from this board. That's a waste of time. So I needed to figure out a way to get this programmed. So the first thing I did was I found a template online for the program Fritzing for this particular part, and so I was easily able to create a breakout board for it and get it soldered on there with all of the labels. Because on the back, I just keep dropping stuff. On the back of this chip, it's not going to come into clear view here, but on the back of this chip, you can see the pinout and what all the pins are. And so basically, I took that and applied it to here, and so you can see the pinout was brought to the top. But I added all the ones at the bottom and brought those to the top as well. There's 6 pins on the bottom of this chip, so I brought 3 to one side, 3 to the other. So anyway, I plugged this into my breadboard and wired up everything, and my only flaw was that when I plug it into the breadboard, I'm not given much gap. I didn't think about this. This black piece right here underneath the board, that's the only amount of room I had between the bottom of the plugs and this thing. So I couldn't get any wires underneath there because I couldn't plug this on top of the wires. The headers on the wires were too big. So I had to get some female headers and put them into the breadboard first to raise this up a little bit. And even then, it's like you can't get underneath to wire it. It was too wide for the breadboard, so there's just a lot of challenges with this particular design, but it functions. I can get it into a breadboard no problem and do the basics. The one thing that I needed So that got me from this step to this step. To get this programmed, what I needed was a USB to serial UART interface. And I got this thing off of a phone app called Geek for like $1. Took about a month to get here, but you know, I could get 6 of them and not even blink an eye at it. So anyway, that's what I needed. So I plugged this into the breadboard. Now, the main thing about these things, I forgot, is that these don't run on 5 volts. They run on 3.3 volts, I've learned. So I guess you can seriously do some damage by plugging it into 5 volts. Me, being the type, of course, I plugged it into 5 volts. It still works. So either it's a very hardy little part, or I got very lucky. Anyway, so they run on 3.3. So this has a jumper where you can select between 5 volts and 3.3. So I selected 3.3, plug it into the computer, take power from here. Now this a lot of people say that there isn't enough power from this device to be able to power your ESP, but I had no problem at all. I just had some connection issues. That was my biggest deal. Anyway, I took power from here to supply here. Made the necessary connections. I don't need to go into that. There's plenty of videos on there. So with those two things paired, I was going. I was good. I got this to connect. I was still able to do my little program that I had written for my phone. So then I decided, to be able to program this chip, well, this thing's soldered down. Well, I can't program any other chip, and I'm going to need one for my actual project. So I took that same footprint. Yeah, the same layout, the same footprint for fritzing, and made a new board, but made it as a programming socket. So it's got all of these little rounded pins that are sitting in holes that, let's see, let me get a pointer here. So they're soldered at this point, and they come over here to the male header, which goes down to this green board. But the wire is bent, and then it goes into this hole. It's a little oversized. It's bigger than the actual wire itself, so it gives it a little bit of springy action, just a little bit, just a little give, just enough to be able to take the ESP-12E and plug it into a socket. Righteous. So I got that done. And then this plugs into here. There's my converter. I plug this into my computer. I hold down my enable and my GPIO 10 button. And we're rocking and rolling, and we're programming. Now, I haven't actually been able to test this chip to make sure it works. I wired an LED to one of the output pins here, but I have yet to been able to program this to get this light to blink, so I don't know if that actually works. So my next step is, once I'm able to program this, I want to be able to pop it into my project. Just like you would put an IC chip, like a PDIP, into some kind of IC socket. That's what I'm trying to get here. And I couldn't find anything reliable online, just big things, but I found some 3D printable items. My 3D printer isn't the best, but this kind of gives you the idea. It's kind of the same idea as the board. So I'd be able to put my pins into here, and the pins go into these holes where they're not soldered down, and this is where there's a little bit of spring action. But anyway, I made this last guy, and then this guy is just a test to make sure that my individual program chip is working before I actually solder it into my project. I haven't fit this into the socket yet, and I'm not about to try to do this on camera because I can already see that I'm going to have to do some adjustments, so I'm not going to waste time with that right now. But anyway, I wanted to get a little bit of this on video before I forgot, because this was my kind of step-by-step adventure into the world of the ESP-12E, and then eventually into the ESP-01. I mean, that's kind of stepping back, I guess. But the ESP-01 is going to be used for a much more awesome project, something to upgrade a project that I've worked on years ago. So, all right, that's it for now.